Why are oceans salty? Anyone who's been knocked over by a wave at the beach knows that the ocean tastes like salt. This is true whether you swallow a mouthful of seawater off the coast of Queensland or the Jersey Shore. The ocean's salinity is one of the defining features separating it from freshwater bodies like lakes and rivers. But what is it exactly that makes the ocean saltier than a bucket of boardwalk fries? If you're curious about the science behind everyday mysteries, don't forget to subscribe for more fascinating videos like this. What is salt, exactly? Let's start with what salt is and where it comes from. Chemically speaking, a salt is a compound composed of two groups of oppositely charged ions. When an atom contains more protons than electrons, it becomes a positively charged ion. Atoms with more electrons than protons are negative ions or anions. Atoms with opposite charges attract one another to form chemical compounds. The chemical composition of table salt is sodium chloride, with sodium being the positive ion, and chloride being the negative one. Sodium and chloride also make up most salt in the ocean, but they're not the only minerals contributing to the sea's salinity. Salt in the ocean isn't just sodium and chloride, it's a mixture of a bunch of ions like magnesium and calcium as well, most of which start out as rocks on land. Dr. Morgan Raven, an organic geochemist and geobiologist and associate professor of earth science at the University of California, Santa Barbara, tells Mental Floss. Sources of the ocean's salt. Most of the ocean's salt comes from rocks. The dissolved carbon dioxide in rainwater makes it slightly acidic, and when rain falls, it erodes rocks on land. Minerals from these rocks leach into rivers and streams, which then carry the salts into the ocean. About 85% of the ocean's ions are sodium and chloride, while magnesium and sulfate make up around 10%. Not all salt that ends up in the ocean stays there. Salt is a life-sustaining substance, and a lot of the ocean's salt is consumed by animals. But thanks to a steady supply of runoff from the surface, salinity levels are able to remain fairly constant. The ocean can count on one more source for its salt content: hydrothermal fluids. Deep-sea vents are heated by magma from beneath the Earth's crust, and they get hot enough to cause chemical reactions between seawater and minerals from the surrounding rocks. Underwater volcanoes are another example of hot rocks and water adding more salt to the sea. Saltwater versus freshwater. Every part of the ocean is salty, but just how salty varies depending on where in the world you are. One of the reasons that oceanographers love to use salinity to study the ocean is that there are only a few ways that it can change, and they all happen at either the ocean surface or the sea floor, Raven says. For example, surface water in the Mediterranean Sea is saltier than the equatorial Pacific because enhanced evaporation in a dry climate concentrates salt, while rain at the equator dilutes salt. Salinity isn't inherent to seawater. It's the result of a steady give and take of ions entering and leaving the ocean. This same process occurs in other bodies of water, but the ion intake isn't always high enough to make the water truly salty. That's why the rivers and streams that deliver salt to the ocean are still considered fresh water. Dilution from the rain tends to offset whatever ions they carry. The ocean meanwhile acts as the dumping ground for the world's salt, and no amount of dilution can change that.